Imagine stepping onto a rocket, waving goodbye to Earth, knowing deep in your heart that you might never see home again. Not because you don't want to, but because you can't. This isn't science fiction. This is the brutal reality facing the first humans who will journey to Mars. Today, we're going to uncover the shocking reasons why a trip to the red planet might be a one-way ticket, and why even the most advanced technology might not be enough to bring our brave explorers home. Let's start with something simple: distance. Mars isn't just far away, it's incomprehensibly far. At its closest approach to Earth, Mars is still 34 million miles away. That's about 140 times the distance to the Moon. But here's where it gets really interesting. Space doesn't care about our convenience. Earth and Mars orbit the Sun at different speeds. Think of two runners on different lanes of a track. Sometimes they're close, sometimes they're on opposite sides. This means the distance between our planets constantly changes. At their farthest, Mars and Earth are separated by a staggering 250 million miles. Now, you might think, okay, we'll just wait for them to get close again. Smart thinking. But there's a problem. These optimal alignment windows, what scientists call launch windows, only occur once every 26 months. Miss your window, and you're waiting over 2 years for the next one. But here's the real kicker. The journey itself takes between 6 to 9 months one way. That's half a year to a year of your life, floating through the void of space just to get there. And if you want to come back, you're looking at another 6 to 9 months. We're talking about a minimum mission duration of 2 to 3 years. And that's if everything goes perfectly. Now let's talk about something that might seem boring, but is actually terrifying: fuel. Getting to Mars requires an enormous amount of propellant. The rocket that takes you there will burn through hundreds of tons of fuel just to escape Earth's gravity and set course for Mars. Here's where the nightmare begins. If you want to come back, you need fuel for the return journey. But you can't just pack all that fuel on the initial launch. It would make the spacecraft impossibly heavy. You'd need fuel to carry the fuel, and fuel to carry that fuel. It's called the tyranny of the rocket equation, and it's a brutal mathematical reality. The proposed solution? Manufacturing fuel on Mars itself. Scientists call this in situ resource utilization, or ISRU. The idea is to use Mars's carbon dioxide atmosphere and extract water from Martian ice to create methane and oxygen, which can be used as rocket fuel. Sounds brilliant, right? But here's the problem. This technology is still largely theoretical. We've never done it on Mars. We'd need to send fuel production equipment ahead of time, equipment that would need to work flawlessly in Mars's harsh environment without human supervision for months or years. One malfunction, one component failure, and suddenly your return ticket evaporates. And even if the fuel production works perfectly, you'd need to produce enough fuel to fully load a spacecraft capable of escaping Mars's gravity and surviving a 9-month journey back to Earth. We're talking about producing tens of tons of fuel using equipment that's never been tested in those conditions. Would you bet your life on that? Let's get personal. Let's talk about what happens to your body, because this is where things get truly disturbing. The moment you leave Earth's protective magnetic field, you're bombarded with cosmic radiation. We're not talking about the kind of radiation you get from an X-ray. This is high-energy particles screaming through space at nearly the speed of light, tearing through your spacecraft, through your spacesuit, through your body, and damaging your DNA at the cellular level. On Earth, our magnetic field and atmosphere protect us. On the International Space Station, astronauts still get some protection because they're still relatively close to Earth. But on the journey to Mars, you're exposed. Studies suggest that astronauts on a Mars mission could receive radiation doses 1,000 times higher than what we experience on Earth. This radiation doesn't just increase your cancer risk, It can cause acute radiation sickness, damage your central nervous system, increase your risk of cataracts, and potentially cause cardiovascular problems. And here's the really scary part. We don't fully understand the long-term effects because no human has ever been exposed to this level of radiation for this long. But wait, it gets worse. In microgravity, your body starts to fall apart. Without the constant pull of gravity, your bones begin to lose density at a rate of about 1 to 2% per month. Your muscles atrophy. Astronauts on the International Space Station exercise for 2 hours every single day just to slow down this deterioration, and they still come back weaker. On a mission to Mars, you'd spend 6 to 9 months in microgravity getting there, then time on Mars, which has only 38% of Earth's gravity. Then another 6 to 9 months in microgravity coming back. Your bones would become brittle, your muscles would waste away, and your cardiovascular system would weaken. There's also the fluid shift. In microgravity, the fluids in your body redistribute upward. This causes your face to swell, increases pressure on your optic nerves, which can damage your vision, sometimes permanently. Some astronauts have returned from space with permanent vision changes. And let's not forget your immune system. Studies have shown that spaceflight weakens the immune system. Dormant viruses in your body can reactivate. Your ability to fight off infections decreases. On Earth, this is manageable because you can come home. On Mars, you're 140 million miles from the nearest hospital. After years of this punishment, would your body even be capable of surviving the journey home? Could your weakened heart handle the stress of re-entry? Could your brittle bones withstand the G-forces? These aren't rhetorical questions. We genuinely don't know the answers. Now let's talk about your mind, because isolation does things to people that we're only beginning to understand. You'd be confined to a small spacecraft or habitat with the same handful of people for years. No fresh air, no nature, no spontaneity, no escape. Every conversation, every meal, every moment shared with the same faces, day after day after day. The psychological term for this is ICE, isolated, confined environment, and it's known to cause severe psychological stress. Studies from Antarctic research stations and submarine crews show that even the most mentally stable individuals can develop anxiety, depression, and interpersonal conflicts in isolated environments. And those people knew they could eventually leave. Imagine knowing that you're farther from home than any human has ever been, and that rescue is literally impossible. The communication delay alone is maddening. At its closest, there's a 4-minute delay between Mars and Earth. Say something, wait 4 minutes for a response. At its farthest, that delay stretches to 24 minutes. You can't have a real conversation. You can't call home when you're feeling down. You can't get real-time support during a crisis. There's also the overview effect's dark cousin. Astronauts who see Earth from space often report a profound shift in perspective, a sense of unity and fragility of life. But on Mars, Earth would appear as just another star in the sky. That psychological anchor to home, that visual reminder of everything you're working to return to, gone. Some psychologists worry this could trigger existential crises or severe depression. Sleep disorders are almost guaranteed. Without Earth's natural 24-hour light-dark cycle, your circadian rhythm goes haywire. Mars has a slightly longer day, about 24 hours and 40 minutes, which might seem close enough, but studies show that even small disruptions to circadian rhythms can cause chronic sleep deprivation, which leads to impaired judgment, decreased cognitive function, and increased risk of accidents. And here's something truly chilling. What happens if someone has a severe psychological breakdown? On Earth, we have hospitals, therapists, medications. On Mars, you'd have limited medical supplies and crew members with only basic training. You can't sedate someone for months until they get home. One person's psychological crisis could endanger the entire mission. Let's talk about the machines that would keep you alive, because they would need to work perfectly for years. Life support systems on a Mars mission would be far more complex than anything on the International Space Station. You'd need to recycle air, water, and waste with near-perfect efficiency. One major failure in your oxygen generation system, and everyone dies. One contamination in your water recycling system, and everyone gets sick. These systems would need to operate for years in an environment they weren't tested in, subjected to temperature extremes, dust storms, and radiation that could damage electronic components. And here's the thing about complex systems. They fail. It's not if, it's when. The spacecraft itself would be subjected to micrometeorite impacts. Space is full of tiny debris traveling at thousands of miles per hour. A grain of sand moving at 20,000 miles per hour has the kinetic energy of a bullet. Your spacecraft needs to withstand this bombardment for months. Then there's the landing. Mars has an atmosphere, but it's thin, just 1% the density of Earth's. This creates a unique problem. It's thick enough to generate heat during entry, requiring heat shields, but too thin to slow you down enough with parachutes alone. You need a complex combination of heat shields, parachutes, and retro rockets, all timed perfectly. We've successfully landed rovers on Mars, but landing humans is a completely different challenge. You need a much larger, heavier spacecraft. The margin for error is razor thin. One computer glitch, one sensor failure, one miscalculation, and you crash at hundreds of miles per hour. And remember that return vehicle? Even if you successfully produce fuel on Mars, that spacecraft has been sitting on the Martian surface for months or years, exposed to dust storms, temperature swings from minus 125 degrees Fahrenheit at night to 70 degrees Fahrenheit during the day, and constant radiation. Will the seals still work? Will the computers still function? Will the engines fire when you need them to? You'd essentially be betting your life on a vehicle that's been sitting unused in the harshest environment imaginable, hoping it starts on the first try because you won't get a second chance. Now let's talk about something less dramatic but equally important: money. A human mission to Mars would cost hundreds of billions of dollars. NASA's current estimates range from $400 billion to $1 trillion for a sustained Mars program. That's an almost incomprehensible amount of money. Here's the brutal economic reality. Rescue missions are even more expensive. If something goes wrong, if astronauts are stranded on Mars, launching a rescue mission would require years of preparation and cost tens of billions of dollars more, and there's no guarantee a rescue mission would arrive in time. Governments and private companies planning Mars missions are making calculated decisions. In the cold logic of budgeting, the resources required for a robust return capability might be seen as too expensive, especially if mission planners are already comfortable with the idea of one-way trips. Elon Musk has openly discussed the possibility of people dying on Mars, treating it as an acceptable risk for the advancement of humanity. While there's something admirable about that pioneering spirit, it also reveals the underlying assumption: return isn't guaranteed and might not even be the priority. From a purely economic standpoint, one-way missions are cheaper and simpler. You don't need return fuel, you don't need a return vehicle, you don't need to maintain systems for as long. If the goal is to establish a permanent Mars colony, then the people who go are expected to stay, to build, to live out their lives there. This creates a disturbing scenario where the first Mars explorers might be sold on the dream of being pioneers, while the fine print acknowledges they're probably never coming home. Let's imagine you've made it. You've survived the journey, successfully landed, and you've been living on Mars for months or even years. Here's a question nobody wants to ask. Would you even want to come back? Your body has adapted to Mars. Your bones have adjusted to the lower gravity. Your cardiovascular system has recalibrated. Returning to Earth's gravity would be like suddenly tripling your weight. Every movement would be exhausting. Standing would be painful. Your weakened bones might fracture under the strain. There's a very real possibility that after a certain amount of time on Mars, returning to Earth becomes medically inadvisable or even impossible. You might have passed a point of no return not because the technology failed, but because your body has fundamentally changed. Then there's the psychological adaptation. If you've spent years building a life on Mars, establishing routines, contributing to a colony, Earth might start to feel foreign. The people you left behind have moved on. Society has changed. You'd be returning to a world where you no longer quite fit, where nobody truly understands what you've experienced. Some psychologists speculate that long-term Mars colonists might develop a distinct cultural identity, a sense of being Martian rather than Earthling. At that point, Earth isn't home anymore. Mars is. And here's a darker thought. What if Earth decides you're too contaminated to return? The possibility of Martian microorganisms, however unlikely, could trigger planetary protection protocols. You might be quarantined indefinitely, or worse, denied re-entry entirely. Imagine surviving Mars only to be told you can never touch Earth's soil again. So when exactly does a Mars mission become one way? The answer is, there are multiple points of no return, and they start earlier than you might think. The first point of no return is economic and political. Once governments and private companies commit to a Mars program, the sunk cost fallacy kicks in. Billions have been spent. Careers have been staked on success. The political will to fund a full return capability might evaporate in favor of just getting people there. The second point of no return is at launch. Once you leave Earth, you're committed. There's no turning back mid-flight. If you discover a problem with the return vehicle or fuel production system, tough luck, you're already en route. The third point of no return is medical. After several months in space and time on Mars, your body may no longer be capable of surviving the return journey. This could happen gradually, almost imperceptibly, until one day you realize you've crossed a threshold. The fourth point of no return is technological. If the return vehicle fails, if fuel production doesn't work, if a critical system breaks down, you're stuck. And unlike in the movies, duct tape and ingenuity might not be enough. The fifth point of no return is psychological. After years on Mars, the idea of returning might become more frightening than staying. The known dangers of Mars might seem preferable to the unknown challenges of reintegrating into Earth's society. This brings us to deeply uncomfortable ethical questions. Is it right to send people on a mission knowing they might never return? Where's the line between brave exploration and reckless endangerment? Astronauts are informed volunteers. They know the risks. But do they really? Can anyone truly comprehend what years of isolation, radiation exposure, and physical deterioration actually feel like until they're experiencing it? Can you give informed consent to something so far beyond normal human experience? There's also the question of selection. Who gets to go to Mars? Would we send young people in their prime, knowing they're sacrificing decades of life on Earth, or older volunteers who've already lived full lives? Either choice feels morally complicated. And what about the people left behind? The families who say goodbye knowing they'll probably never see their loved ones again? The children who grow up with parents on another planet, communicating through 24-minute delayed messages? Some ethicists argue that one-way Mars missions are fundamentally different from historical exploration. When humans crossed oceans or explored new continents, they faced danger, but they could potentially return. Mars might be the first human exploration where return is physically impossible, creating a new category of existential commitment. But let's not end on complete despair. There are scenarios where return becomes possible. though they require technological breakthroughs we haven't achieved yet. Advanced propulsion systems like nuclear thermal rockets or even theoretical technologies like fusion drives could dramatically reduce travel time, cutting the journey from months to weeks. Faster travel means less radiation exposure, less time in microgravity, and fewer opportunities for things to go wrong. Artificial gravity through rotating spacecraft could solve the bone and muscle deterioration problem. Imagine a spacecraft that spins, creating centrifugal force that mimics Earth's gravity. Astronauts could maintain their physical health during the journey, making return much more feasible. Better radiation shielding, perhaps using water, hydrogen-rich materials, or even electromagnetic fields, could protect astronauts from the worst cosmic radiation. Some designs propose surrounding crew quarters with water tanks, which would block radiation while also serving as a resource. Advances in medical technology, especially in gene therapy and regenerative medicine, might allow us to repair radiation damage or stimulate bone and muscle growth even in low gravity. We might develop pharmaceuticals that dramatically reduce the physiological impacts of spaceflight. And in situ resource utilization might actually work if we can reliably produce fuel, water, oxygen, and even building materials on Mars. The return journey becomes exponentially more achievable. The key word is reliably. We need to prove this technology works before we stake human lives on it. So here we are, at the end of our journey through the brutal realities of Mars exploration. The truth is sobering. With our current technology and understanding, anyone who goes to Mars is taking a tremendous gamble. They might return as heroes. They might die trying. Or they might spend the rest of their lives on a cold, barren world, 140 million miles from everything and everyone they've ever known. But here's the thing about humanity. We've always been willing to venture into the unknown. We've crossed oceans in wooden ships. We've climbed mountains that kill. We've split atoms and walked on the moon. Each time, people said it was impossible, too dangerous, not worth the risk. And each time, someone stepped forward anyway. The question isn't whether going to Mars without a guaranteed return is crazy. It absolutely is. The question is whether it's worth it. Whether the potential to expand human civilization beyond one planet to ensure our species' long-term survival, to answer the profound question of whether we're alone in the universe, justifies the sacrifice. For some people, the answer will be an emphatic no. They'll choose the safety and comfort of Earth, and there's no shame in that. It's the rational choice. But for others, a small number of brave or perhaps reckless individuals, the answer will be yes. They'll volunteer for a one-way trip to Mars not despite the risks, but because of the opportunity. They'll trade the rest of their lives on Earth for the chance to be pioneers of a new world, to have their names written in history alongside the greatest explorers humanity has ever known. And when that first spacecraft departs for Mars, when we watch it disappear into the sky carrying humans who may never return, we'll be witnessing something unprecedented. The moment humanity consciously chose to become a multiplanetary species. Whatever the cost, the real question isn't whether anyone who goes to Mars will return. The real question is whether we're ready, as a civilization, to accept that some frontiers require permanent pioneers, and whether we can honor their sacrifice while doing everything in our power to make their new world worth the price they've paid. The age of Mars exploration is coming. The only question that remains is, would you go?